integrity is everything. Our way of life in this country rises and falls on the integrity of our leaders and the integrity of our infrastructure. Because integrity impacts everything, this is the Integrity Podcast, powered by EXO, hosted by Zachary Oliphant.
Well, what a fantastic opportunity to interview Clinton Char, industry icon's been around for probably close to 35, 40 years in our industry.
Been around for about 32 years.
32 years. So just getting started.
Yeah, just getting started. Yeah.
So what a fantastic opportunity. I get an opportunity to huddle and chat with you, Clinton. And I always like to start with maybe just give me a little bit of your background story. What was the impetus of getting into engineering? Were you just really good at math and you gravitated into engineering, or was there a mentor of yours that helped maybe funnel you in that direction? Okay. So maybe give me your backstory.
Yeah, okay. Yeah, my name's Clinton Char. I was born and raised in Hawaii. And the influence that really got me into civil engineering was my dad. I remember when I was a little kid, my dad used to bring home his work. He used to bring home drawings, and I would kind of follow him and see what he's doing. And it really got me interested into civil engineering. So that's my background as far as getting into engineering.
Now was he an engineer as well?
He was a civil engineer in Hawaii.
Oh, awesome.
Exactly.
Now, was he doing building work, or what kind of work was he doing?
He was actually doing building work. He worked for the state of Hawaii in the Public Works Department, so he was mainly doing buildings.
Okay.
So I thought that when I would grow up, I would be doing exactly like he was doing designing buildings and bridges. That was my original goal when I was a kid.
Oh, yeah. Fantastic. So then you went off to school, and you thought all along that you wanted to go off become a civil structural engineer. Were you thinking you're going to be doing buildings or civil projects, or what brought you into the utility space? That's
kind of interesting because when I grew up, initially when I was a kid, I wanted to do what my dad was doing, buildings and bridges. But when I grew up, I really got an interest in aviation, aviation and space. That was really one of my interests that I had. So when I actually went to school, I actually wanted to get into the structural engineering of either spacecraft or airplanes. So I went to University of Hawaii for my bachelor's, got my master's from Purdue University, and my first job was actually at the Hughes Aircraft Company then, and I was designing communication satellites, the structural components. So I really had an interest to get into aviation and aerospace. That was my goal. But after 4 years being in aerospace, I wanted to move back to Hawaii. And, the job that I had was in California, of course, which is the hotbed of aviation at that time. So after 4 years there, I decided to move back to Hawaii. And Hawaii, there's no such thing as high-tech aviation jobs. So I took a job at the Corps of Engineers. Okay. And the job I had was a project manager. And I didn't know what project management was. And the more I got into it, the less I really liked the job because I really wanted to use my technical skills. Mm-hmm. So after 8 years at the Corps of Engineers, I decided to look around. I wanted to find a job that would give me an opportunity to use my engineering structural analysis type work. So one day I remember I saw this ad in the local paper in Hawaii for a structural engineer for Hawaiian Electric Company. So I applied for it, and they set me up for an interview. So I went for the interview at with Hawaiian Electric Company, and I remember during the interview, my boss at that, my potential boss, indicated that, you'll be designing poles, and I'm thinking to myself, poles, one size fits all. Why do you need to design a pole for a utility company? So I was a little bit disappointed because I wanted something a little bit more technical. Mm-hmm. But my dad told me at that time, said, you should go to Hawaiian Electric Company because everybody needs electricity. You have job security.
Absolutely.
So I took the job, and at Hawaiian Electric Company, they designed tubular steel poles. And I didn't know at that time when I started how technical and complex designing poles are.
Exactly.
So when I did that, I really got involved, and I really enjoyed being in the utility industry.
Well, fantastic. And the terrain that you have to navigate in Hawaii to build transmission lines is not easy.
Yes.
Which makes it really difficult to design structures and route lines through hills and mountains. Yeah. So then post Hawaii Electric, what brought you to Southern Cal Edison?
So the thing about Hawaiian Electric Company is that the transmission voltage is 138 kV. Mm-hmm. And I really wanted more experience in high voltage, 220 and 500 kV. So I actually decided to apply for Southern California Edison. And again, they set me up for an interview, and they liked what I had to offer. So they actually gave me a position, and I decided to move to California.
Oh, fantastic.
Yeah.
So walk me through maybe a couple of the big projects you worked on there. Southern Cal Edison's done some of the biggest
Yes.
voltages in the U.S.
Yeah.
Maybe walk me through some of those projects, challenges,
Yes.
accomplishments, those sorts of things.
So the biggest project that I worked on at Edison, I was at Edison for 13 years. The biggest project I worked on, and the project of my career, it has been the Tehachapi Renewable Transmission Project, or TRTP. That was actually a $2 billion project where they were running a new 500 kV line in from the Tehachapi area, bringing renewable energy into the LA basin. So that was a very extensive project. I was on that project for about 5 years, and we did everything. We did the design, we did the procurement, we supported construction, and I really enjoyed that project. I think that's, like I said, the crowning point of my career in the utility industry.
Any particular challenges on a project of that size? I'm sure there were, that you had to overcome, and maybe some advice for folks on how to deal with the challenge and maybe how to overcome that challenge?
We had a lot of challenges on that project. We had the public. We had to run a new transmission line from the northern part above LA into the basin. We had to deal with right-of-way issues. We had to deal with public issues. And the worst thing about California is you had to deal with environmental issues. Yep. So a big part of that project was dealing with environmental issues. And, for instance, there were certain times where in certain areas birds were fledging, so you couldn't do construction. So we had to time the construction based on that. We had to address, get public support. So a lot of times we had to go to these public meetings, and we got a lot of input from the public into telling us what type of structures we needed to put in. So if you look at the project right now, a lot of the areas in north of LA would be lattice steel towers. Mm-hmm. But if you come down into the LA basin, we had to use tubular steel poles.
Absolutely.
And we had to paint them a certain color to blend them in with the background. So there's a lot of issues that we had to deal with, especially being in California.
Absolutely, yeah. No, it's not getting easier to build transmission lines, especially high voltage transmission. And certainly utilities work very hard to get public input.
Yes.
Deal with all the environmental issues, construction constraints. Right. Manufacturing constraints. I mean, all the various sorts of constraints that are in our industry. And people want to do all that and have reliable power at the same time, right? And so that's always a balancing act for a utility.
Exactly.
Utilities quite often get beat up when the power turns off every now and then, or there's an outage. But they don't always get the credit for all the work and planning and effort they're putting in to plan 10 or 15 years out.
Yes.
On transmission demands, siting, and all the other things that have to be done to build a big project like that.
Yeah.
So that's fantastic. Maybe walk me through some examples in your career that you would give advice to young engineers that are coming into our industry. Someone just coming out of school, maybe they're coming out of Purdue, and they're looking to jump into our industry. And right now, there's very similar to maybe your when you were coming out of school, space is gotten busy again, and so that's pulling engineers. You've got a lot of brilliant people going into AI and other kind of computer science type careers. What would you give advice to a young engineer coming into our industry, the power industry?
I would say consider the power industry, because throughout my career, I've always wanted to give back to the general public, community service. And my thinking is that by working for a utility, you are taking the information that you're learning in school and applying it to the better good of the community. Everyone needs power, as you indicated. Renewable energy is becoming a big thing now. And we're always going to need engineers to kind of support that. So my thinking is that it is kind of a good way to give back to the community as far as your career is concerned. And that's been my job satisfaction too. like when I go back to Hawaii, I still see some of the structures that I designed, and I tell my daughters, hey, I designed that structure. And sometimes they're amazed. It's like, wow, you did that, Dad? And that's standing on the top of the hill. Yep. So it's really rewarding to get into this industry. One of the things I would have, though, is for young engineers is, with all these automation that we have, like PLS CAD and everything's being automated, I think one of the key things that they need to do right now is they got to understand the basic theories. That I think is important, because if you understand the basic theories, you can understand what's coming out of PLS CAD. If you don't understand the theory, what comes out of a computer program like PLS CAD or SAPS or whatever may or may not be right. You need to get that feel that information is correct. And the only way you can do that is to understand the theory.
That's right. You probably started at a time. My dad started in the career in the utility space a little earlier than you, but he started with slide rules, Big Chief tablet calculations, before computers, and he echoes the same sentiment, right? The theory is so important for young engineers to understand. Exactly. You can't just stick it in a computer and trust that everything is perfect. You've got to understand where it's coming from.
Yeah. I'm a little bit after your dad. I didn't use slide rules. We had calculators then, like the HP calculator. I had that. And then we had sag curves that we used, to plot the actual sags on design drawings. So I had that. So I was a little bit after your dad.
You had the next step in advancement in technology.
But before PLS CAD.
Yeah, before PLS CAD for sure. So talk to me a little pivot to the paper you're giving at TS DOS this week. I think it's a really interesting discussion that is probably really important right now. I mean, Texas is going through record heat. I think the U.S. had the highest global temperature this summer, probably in a couple 100,000 years.
Yes.
That puts huge demands on the power industry. That puts huge demands, certainly in areas like I live in Houston, where we're used to getting a lot of rain, going through a pretty severe drought that creates wildfire issues. So maybe talk to me a little bit about the paper that you and Dr. Z were presenting this week, and maybe look forward towards the future with ongoing climate, heat issues, wildfire issues, how that may affect our industry.
Yeah. So in the last 5 years that I was at Edison, as you know, about 5 or 6 years ago, they had a series of wildfires in Southern California. So during those wildfire events, at Edison, they actually started to become more concerned about addressing and mitigating and reducing the instances of initiating a wildfire. So I really got involved in that from the structural perspective. And we looked at a lot of different things. I was involved in the PSPS program, which shuts off power when the winds hit a certain area. I was involved in that. I was involved in looking at structural materials that would be more fire resistant in a wildfire. I was involved in that. And I was involved in more like the maintenance issues, where we had to look at our existing structures to make sure that they were up to speed, I guess. They didn't have corrosions, and they were the structural integrity was there. So I was involved in all those fronts. So one of the things that we're presenting at this conference is a paper that we did on looking at the behavior of lattice steel towers under wildfire conditions. As you know, steel doesn't burn. And a lot of people think that because it doesn't burn, it's okay. But what happens is that what we found is that if steel is exposed to heat of a wildfire at certain temperatures, it does change the metallurgical characteristics of the steel to the point where you could have some strength degradation in the steel. So we did a lot of studies about that, and that's what we're presenting at the conference, in that we are looking at the structural integrity of the metal itself. Because in certain instances, if the temperature is high enough, you could actually weaken the steel.
That's right.
And if the utility is not aware of that, they could assume that the steel is of a certain strength and assume that it still meets the required factors of safety. However, if you don't realize that the steel has been compromised, you could have steel that is actually less than the required factors of safety for the structure. So you could have structure failure in the future. And then the other thing too is that if the temperature reaches a certain level, you could melt the galvanizing on the steel. So your structure would be more susceptible to corrosion in the future because of that. So we just kind of want to bring that to everyone's attention with our paper.
Absolutely. And most people think in wildfires it's primarily the distribution system that's under attack because of the wood pole content.
Right.
But you're right. The other materials can see damage as well.
Yes.
And they're usually the backbones of your system.
That is correct.
If a distribution line or a segment that's a small tap going into a neighborhood goes down, you may have 100 people without power.
Right.
A 500 kV transmission line goes down, you're going to have a lot of people without power.
Exactly.
And so it becomes a really, really big problem.
Yes.
Yeah, so maybe as a little segue, Clinton, you and Dr. Z presented this paper on wildfires that you were dealing with in California. Obviously, your home state of Hawaii, you spent a lot of time in Hawaii, just dealt with a terrible, catastrophic wildfire that I think, at least in some initial reports, was maybe tied to the electrical grid, some arc flash, coupled with the really high winds that were going on. Maybe give some context or your thoughts there.
Sure. Okay. I'd be glad to. Yeah. So I still keep in contact with a lot of my ex-colleagues at Hawaiian Electric Company. And certainly what happened on Maui was severely tragic. I mean, it's had a great loss of life, loss of property, and basically the town of Lahaina has been burned to the ground and wiped off the map. So certainly very tragic there. My thinking, though, is that the situation there is the Hawaiian Electric Company is not as robust as any of the mainland utilities like Southern California Edison or PG&E because they haven't really gone through a major wildfire. This that has affected people. Previous wildfires have been in areas which are in forested areas or grassland areas where not too many people were affected. But this is the first time that they had a wildfire that has affected a lot of people. So similar to what Edison was 5 years ago, we have at that point we have not experienced any wildfire. So we didn't really have a wildfire program in place. It's similar to what Hawaiian Electric Company or Maui Electric Company had. They were really unprepared and didn't have any wildfire program in place. So my thinking though is that this is kind of a wake-up call. I think Maui Electric and Hawaiian Electric Company were aware of the programs that Southern California Edison had, and PG&E had, where you would do PSPS, shutting off power at certain wind speeds, and using covered conductor for distribution lines at high fire areas. So I think they were aware of it, but I think that because they haven't had any issues in the past, that it wasn't a key thing for them to do. From what I understand is that they did have programs in place where they were eventually going to address it. But because they haven't had anything in the past, it really wasn't brought up, up front.
And that's always a tough debate for utilities, right? Which is how proactive to be on an issue that may or may not happen, especially when you're dealing with limited dollars sometimes.
Yes, exactly.
And trying to put the right dollars in the right places where you've got ongoing inspection and maintenance work on some of your older structures. A lot of utilities have structures that are 80, 90, 100 years old that have to be maintained.
Exactly.
So do you put dollars into the aging infrastructure? Do you put dollars into fire mitigation?
Right.
Do you put dollars into building new transmission grid
Right.
Or distribution system?
Right.
Or do you harden against hurricanes, right? Hawaii Electric now has to deal with two issues, right? The
Right.
hurricane issue and fire issue. Which most utilities only have to deal with one,
Right.
Not both.
Right.
And so that does create some real challenges for utilities moving forward.
Right.
Is where do you put your money and try to mitigate risk and damage, for the folks that are utilizing your power.
Yeah.
Absolutely.
Like utilities, sometimes, they don't realize something is important until something happens. Like, for instance, like Edison wildfires, like 10 years ago, we never thought that, we would need to harden our grid against wildfires. But then we had, a series of wildfires, 5 or 6 years ago where Edison was found to be responsible. I think it's the same thing with Maui Electric Company and Hawaiian Electric Company also, in that even though they did have wildfires, it didn't really affect the population too much as in terms of, damage, economic loss or loss of life. But with this event going on now, I think they really have to look at what was done in California with PG&E or SCE, and kind of follow, what they have learned to kind of grid harden their system against future events. So I think it's a learning experience, but sometimes we have to go through the tough times to actually learn, and I think that's what they're going to have to deal with right now.
Yeah, that's one thing I will say the utility industry does a pretty good job of, which is learning from each other
Exactly.
and each other's mistakes or failures or problems or catastrophic events that
Right.
weren't anyone's fault. And it's interesting. I mean, Florida's been hit recently by a pretty significant hurricane. Seemed to have gotten power back on very quickly. It's probably one of the most resilient power grids in the country. Another Category 4 storm coming. I mean, we have these major storm events
Right.
that are probably tied to climate change, and it's going to be an interesting challenge for utilities to have to continue to deal with
Yes.
over the next several decades
Right.
as they're trying to manage their way through hardening their system and hardening their grid, and do all that while trying to keep power and costs down
Exactly.
for consumers, right?
Yes.
Which is their challenge. So shifting gears a little bit, Clinton, we talk a lot on our podcast about integrity, and our little tagline for our business is integrity is everything. As an engineer, integrity is basically baked into everything you need to be doing every day. Maybe give me some examples of how integrity is important to you personally and in your career, and maybe some advice for more junior engineers or younger engineers.
So to me, integrity is doing the right thing. You know, no matter whether it's at a cost, but being an engineer, when you stamp a drawing, your integrity is on the drawing. You know, you certify that that drawing is done to, the exact specifications, and you put your name on there. So that is integrity, is being able to stamp a drawing. So, and it's doing the right thing.
Yeah.
So there's been many instances in my career where we've looked at things from different perspectives. We've looked at different options. And a lot of times you get pushed into doing the least costly option. You know, because as you indicated a little while ago, you know, there's a balancing act between engineering and costs. But a lot of times things are weighted toward the cost side. But being an engineer, you need to make sure that integrity and you're doing the right thing is first. Even if the lowest cost thing is not the best solution, you need to keep pushing to say, hey, I believe that this is the way that, you know, it needs to be done, even though it's at a little higher cost, because your name is going to be there, and you need to make sure that you maintain your integrity. Because my thinking is that in your career, you're noted for your integrity. If you lose your integrity, nothing can bring it back. You know, it's you basically ruin your career if you lose integrity in the general public.
I love a little anecdote about PE sealing a drawing.
Yes.
And having interviewed a lot of engineers, growing up with an engineer, there is something to be said about saying, I'm going to stamp this and I'm going to sign my name.
Right.
That is different than a lot of other industries and a lot of other folks that aren't required to do that. I've seen a lot of engineers pause and think and say, okay, am I ready? Because my name's going to be on this drawing for the next 50, 60, 80 years. Someone's going to pull this drawing up and try to look at what I did and was it right? And like you said, that's such an important component of our industry, and really, I hope trickles down to lots of other industries as well. Like you said, doing the right thing no matter what. Because at the end of the day, that's all we really have to hang our hats on is doing the right thing. Right. If we all do that, we'll have a good industry.
Yeah. And that's your reputation too.
That's it.
You know, your reputation is built on your integrity. If you lose your integrity, you lose your respectability in the industry.
Absolutely.
And this industry is too small. I mean, you know, if I did something wrong, word would get around, and basically, you know, my career, you know, would probably, you know, be shot at that point. So maintaining integrity is very important.
Well, Clinton, thank you very much for the time. Any other comments you want to give our audience? Any other feedback?
No, I enjoy, you know, I encourage, I guess young engineers to consider a career in utility engineering. Like I told you earlier, I didn't think it was much because I thought about designing poles, but there is a lot of things that go into, you know, the technical design of poles. And I guess, you know, one important things that, you know, I've done in my career is that I'm able to, you know, based on my experiences and everything, is I've been able to serve on ASE committees with your dad. You know, I want to be able to kind of contribute to the community with some of the knowledge that I've gained. And I really appreciate being on ASE committees and presenting papers at conferences. I feel that it's kind of giving back to the younger engineers to kind of help educate them as they proceed through their careers.
Absolutely. Well, Clinton, thank you for all your time in our
you.
industry, and thank you for your time this morning, and really appreciate your insight. So thanks for being here.
Thanks a lot. I really appreciate being here.
Yeah,
I really
thank you.
appreciate it. So thanks so much.